This is mathematical notation. Almost all the concepts of theory of computations, we are using this mathematical notation. Here we can say sigma, another name is called alphabet, that is called input. Suppose you want to derive the name, what is the input? Combination of small letters or caps letters. Suppose you want to form a variable. So what is the alphabet? What is an alphabet? So combination of digits or alphabet, that is a small letters or caps letter, or any specific symbol also we can use. So like that, what are the inputs we are going to use, we can represent as a sigma, that is called alphabet, and one more symbol is called delta. Here we can represent as a transition. For example, if you want to go from this place to another place, so we can represent as a, so suppose you are giving this A, this is a B, so you are representing as a transition of, otherwise delta of A comma A means B. We are reaching from A to B through the input A. So this is this is alphabet. Okay. So like that, for transitions, that is a movement, that is a one place to another place, that purpose we are using this delta, that is a transition. Next we can represent a clean closure, that is a star. We can represent clean closure. Clean closure means we can say it may generate n number of times, not n number of times, it goes infinitively. But the star start with empty transitions. It may be, suppose we are saying A star means, so it will generate the empty string also, 1A also, 2A, 3A, so like that it's going on. So this is a star, clean closure. And plus means the same thing but except epsilon. That's all, we can say it is positive closures. So it will generate infinity times. So this is positive closure. So next we can use the concatenations. Concatenations, we are going to concatenate the two values, for example A dot B, and union either or, we can use either or options, and also if both condition is true, that time we can use and we can say all x, that is universal qualifier. Here for example, for all x square greater than or equal to 0. Some constraint based statement, some properties we can apply for all x, that is universal qualifier. Here you can apply any values and also we have to check the condition. Next one is extensional qualifier. Here we can check whether they exist or not in the given set or given statement or given properties. So that's why you can use the extensional qualifier, that is there exists x. So here x is equal to 4, they are giving the conditions. So definitely we know the solution either -2 or 2. So we are checking the condition whether it is available or not. So that purpose we are using. Next, epsilon transition. Here we can say epsilon transition means empty string or epsilon transitions. That means here we can that is the transitions start from empty string also. That is there is no input, just the machines move from starting state to ending state. That's all. So maybe another input string, it may be so like this. So this is epsilon transitions. For conversion purpose, for computation purpose, we are using this epsilon transition. And for example, this is the example for epsilon transitions. A derives epsilon. So it is A derives nothing like that. So next one is, this is symbol for the starting state. It is always represented as arrow mark with a single circle, and the ending state or final state or accepting state, we can say it's represented as a final state. That's all, almost the same symbol again and again repeated in almost all the automata. That's all. Thank you.